So now we're going to talk about removable discontinuities. I don't make these things up, but this is what they're called. And you may have had some questions about this on another problem, but let's say we have this function, it's a rational function, and you could factor the denominator, right? Okay, so let's factor the denominator. It's going to factor into x minus 3 and x plus 1. So I can say, hey, by the way, x cannot be 3 and x cannot be -1, right? Now, before you go to put the vertical asymptotes in, though, before you want to talk about that, we have to look at another option here. By the way, these numbers are not in the domain. So the domain is still going to be from -infinity to -1, union -1 to 3, union 3 to infinity. I'm going to make it fit. There it is. Okay. Now, let's see what happens. So that's the domain. If they ask, that's the domain right there. They didn't ask, but if they do. So now let's factor the numerator. That factors into x plus 1 and x minus 1, right? It's a difference of squares. And you might notice, oh, look, those x plus 1s cancel. And that's true. But -1 is still not in the domain. And it won't be a vertical asymptote. This is called a removable discontinuity. So there's a removable discontinuity at -1. And what happens on the graph is it creates a hole. In the graph. And so however this graphs, it's going to be, some rational thing. Anyway, we're going to learn how to do that. But it's going to graph, but at -1, there's going to be like a hole in the graph there. So it might go something like this. I wasn't going to take the time to graph it. And then it has asymptotes and stuff. But it's the hole in the graph. So it's like right there. Okay. And it's because these canceled out. Okay, that's what creates the removable discontinuity. So -1 isn't part of the domain. It's not defined there, but it creates a hole in the graph. Okay, so this says find the vertical asymptotes and removable discontinuities of the graph, and it gives us this function. So what we're going to do is we're going to factor. The numerator is just x minus 2, but the denominator is the difference of squares, x plus 2, x minus 2. And so you can see the x minus 2's cancel. And so you have 1 over x plus 2, which you could graph. That would be your rational function, or your reciprocal function, and it's going to be shifted left 2 is what would happen. Okay, but they didn't ask us to graph it or anything. They want the vertical asymptotes. Well, you're going to have a vertical asymptote and it's going to be at x equals -2. So you would still have a vertical asymptote at -2. So think -2. There's the vertical asymptote. And then you're going to have a removable discontinuity. Removable discontinuity. I got to come up with some abbreviations. At x equals 2. Okay, so the graph is going to look something like this, but at 2, so let's see, where would 2 be? 1, 2. It's going to have a hole in the graph. So it's going to do something like this, but at 2 there's going to be a hole in the graph. And it's because that's the factor that canceled when x equals 2. Okay? All right, but this is what they asked for. They didn't ask us to graph it.